Good morning, this is your stat sensei, Mr. Spensei, and this is a warm up on the T interval, and we have exam scores. A college professor has 350 students in a lecture class. She claims that the average score on the final exam is a 75 out of 100. A random sample of 20 exam scores is taken by students and are as follows. And then we're supposed to create a 97% confidence interval for the test scores and comment on the professor's claim. So we have a X bar plus or minus T star S divided by the square root of N. That's our formula. We go to stat edit and we enter the data, which I have all 20 values in there. And there's a couple ways we could go about this. We can go stat calc one var stats L1, and we could get the values that way. So X bar is 75.8, which is actually reasonably close to the professor's claim. Our standard deviation we see is 1.5423. The sample size was 20, so our degrees of freedom are 21, 20 minus 1, or just 19. So we can go ahead and draw this picture. And we know we're going to be centered on X bar because the X bar will always be in the center. We're trying to estimate the population mean. And our X bar in this case was the 75.8. And we have this area right here, which is 0.97, which means we have 0.015 in this tail and 0.015 in this tail. And this is going to be my lower bound of my confidence interval and my upper bound of my confidence interval. And what they ask us to do is we have one sample T interval for means. That's what we've been asked to do. And we need to calculate our T star. To do that, we're going to need to go to inverse T. It's going to ask us for our area. And our area is going to be 1 minus the 0.97, all in parentheses, and divided by 2. And then it's going to ask us for our degrees of freedom, which is, in this case, 19, or the 20 minus 1. You can input it either way. So let's do that. Second vars, inverse T. And we have parentheses 1 minus 0.97, close parenthesis, divided by 2. Degrees of freedom is 20 minus the 1, or just 19. And we end up getting a T star, and make it positive, a 2.3456. And now we can plug into our formula. Well, our X bar, which is the first thing we need for our formula, is 75.8 plus or minus 2.3456 times S, which is 1.5423, over the square root of, make sure you use the sample size and not the degrees of freedom. All right, so now we've shown our work, and we're going to go ahead and calculate our interval. So stat test, drop down to number 8, which is T interval, which is what we said we were going to run. We have data. Our data is an L1. We have our confidence level of 0.97 or 97%. And we have a lower bound of 74.991 and 76.609. So our interval is 74.991 to 76.609. This is my lower and this is my upper. Based on the interval you created in the professor's claim, is the professor's claim plausible? Well, what did the professor claim? Well, he claimed 75. And if I look at my interval, hey, 75 lies within interval. Yes, the professor's claim is plausible. Why? Because, and we could say is plausible to 97% level, because the claim of 75% lies within the interval 74.991 to 76.609. All right. So professor's claim is plausible. Um, they said it would, we calculated a 75.8, which is above the 75. And sure enough, it lies within that interval. 75 lies within the interval. So it looks like the professor's claim is plausible. Appreciate you for watching and hope to see you on the next one. Thank you.